Welcome to this in-depth tutorial where we break down the most important concepts every developer must know when working with Spring Boot. Whether you're just starting out or looking to strengthen your back-end development skills, this video has you covered. In a Spring Boot application, you can declare a bean in several ways. The most common and recommended approaches are 1. Using @bean annotation in @configuration class. Import org.springframework.context.annotation. Bean. Import org.springframework.context.annotation. Configuration. A configuration. Public class appconfig. A bean. Public myService. Return new myServiceImpl. This is a manual way of declaring a bean. A configuration marks the class as a source of bean definitions. A bean tells Spring to manage the returned object as a bean. 2. Using @component and stereotype annotations. You can annotate your class with component, @service for service layer, @repository for persistence layer, @controller for web layer. Import org.springframework.stereotype. Service. A service. Public class myServiceImpl implements myService. Business logic. Spring will automatically scan and register this class as a bean during component scanning. Make sure to use @Spring Boot application or @component scan to enable scanning. 3. Using @component scan explicitly if needed. By default, @Spring Boot application scans the package where it's declared and its subpackages. But you can customize it. @component scan, base packages equals com.example.services. When to use what? Method. Use when. A bean. You need to register a bean manually, e.g., third-party classes, a component, @service, etc., for application-defined classes that Spring should manage automatically. The @REST controller annotation in a Spring Boot application is a convenience annotation that simplifies the creation of RESTful web services. @REST controller. Public class myController. @getMapping /hello. Public string hello. Return hello world. This annotation is essentially a combination of controller, @response body. Implications of @REST controller. Feature. Explanation. Marks the class as a controller. Enables Spring MVC to detect it and map HTTP requests to handler methods. Automatic response body conversion. Every method's return value is automatically converted to JSON or other format and written to the HTTP response body. No need for @response body on each method. Saves you from repeating @response body on every method. Example comparison. Without @REST controller. Controller. Public class myController. @response body. @getMapping /hello. Public string hello. Return hello. With @REST controller. @REST controller. Public class myController. @getMapping /hello. Public string hello. Return hello. Same output, cleaner code. Typical use cases. Building REST APIs that return JSON or XML. Returning data objects, DTOs, not views. Works great with tools like Jackson for JSON serialization. The annotation used to run a method after the Spring ApplicationContext has been fully loaded is @eventListener, ApplicationReadyEvent.class. Import org.springframework.boot.context.event.applicationReadyEvent. Import org.springframework.context.event.eventListener. Import org.springframework.stereotype. Component. Public class startup runner. @eventListener, ApplicationReadyEvent.class. Public void run after startup. System.out println. Application is fully started. Add startup logic here. What it does, runs the method after the Spring Boot application is fully started. All beans are initialized and command line runner/application runner have run. Ideal for tasks like scheduling jobs, loading initial data, triggering startup notifications, health checks, or post-initialization logging. Alternative at post-construct, limited use. At post-construct, public void init, runs after dependency injection, but before the application is fully ready. Executes after bean construction, but before application-ready event. Not ideal for logic that depends on full app startup, e.g., DB connectivity checks. Summary, annotation, when it runs. Best use case. At event listener, application-ready event.class. After full context load, safe for startup logic. Startup scripts, background tasks. Post-construct, after bean initialization only. Bean-specific setup logic. To enable cross-origin resource sharing, CORS, in a Spring Boot application, you have several options depending on your use case. Here's a clear breakdown. 1. Enable CORS at controller or method level. Use at cross-origin on a controller class or a specific handler method. Import org.springframework.web.bind.annotation. Asterisk, at REST controller. At request mapping, /API. At cross-origin, origins equals http / localhost 3000 frontend domain public class myController. At get mapping /data public string get data return hello from backend. Origin specifies allowed domains, can use asterisk for all, though not recommended for production. 2. Enable global CORS configuration. Create a global config class implementing WebMVC configurer. Import org.springframework.context.annotation. Configuration. Import org.springframework.web.servlet.config.annotation.cors registry. Import org.springframework.web.servlet.config.annotation.webmvc configurer. A configuration. Public class webconfig implements WebMVC configurer at override. Public void add CORS mappings. CORS registry registry.addmapping /*** apply to all endpoints. Allowed origins http //localhost 3000 //frontend domain. Allowed methods get, post, put, delete. Allowed headers asterisk. More flexible and centralizes all CORS settings. Suitable for APIs used by multiple clients. 3. Enable CORS with Spring Security, if security is enabled. If your app uses Spring Security, you must explicitly allow CORS in your security config. Import org.springframework.context.annotation. Bean. Import org.springframework.security.config.annotation.web.configuration.enable web security. Import org.springframework.security.config.annotation.web.builders.http security. Import org.springframework.security.web.security filter chain. At enable web security. Public class security config. Bean. Public security filter chain. HTTP security HTTP. Throws exception. HTTP. .cors. Enable CORS. .and. .csrf. .disable. .authorize HTTP requests. .any request. .permit all. Return HTTP.build. Also, register a CORS configuration source bean. Import org.springframework.context.annotation. Bean. Import org.springframework.web.cors CORS configuration. Import org.springframework.web.cors URL-based CORS configuration source. Import org.springframework.web.cors CORS configuration source. a bean. Public CORS configuration source, CORS configuration source. CORS configuration config equals new CORS configuration. Config.addAllowedOrigin, http //localhost 3000. Config.addAllowedMethod asterisk. Config.addAllowedHeader asterisk. URL-based CORS configuration source equals new URL-based CORS configuration source. Source.register CORS configuration / config. Return source. Best practices. Environment. Recommendation. Dev. Use at cross-origin, asterisk, or relaxed settings. Production. Use explicit domains and secure methods only. With Spring Security, always configure both CORS and a CORS configuration source. Subscribe for more backend development tutorials on Spring, Java, APIs, and microservices. Don't forget to like, comment, and hit the bell icon to stay updated.